Welcome to our demonstration of an innovative approach to machine skills training using virtual reality technology. This project introduces an open-ended virtual reality system design for the purpose of training for machine skills, with particular focus on drilling procedures executed via a 3-axis milling machine. Traditional manufacturing training methods encounter challenges of scalability and often restrict adaptability and personalization, limiting their effectiveness for all learners. While recent research has explored XR applications for cognitive skills development, limited focus has been given to open-ended VR systems for manufacturing skills. Many existing VR training systems adopt a closed-guided approach, while our open-ended VR system allows users to foster a deeper understanding of learning materials and enhance their skill acquisition. Our VR training simulation comprises 4 modules. Each module serves a specific learning objective and ensures a comprehensive learning experience. The VR tutorial module allows users to familiarize themselves with the VR controller operations essential for subsequent modules. Through guided instructions, users learn the fundamental actions such as object manipulation and machining instructions. This introductory segment sets the foundation for a comprehensive understanding of the virtual environment. The lab safety module focuses on immersing users in safe practices within the machining environment. Tasks include identifying and rectifying potential hazards, such as removing jewelry, checking clothing and hair for catch hazards, and ensuring that safety goggles are worn. The drilling module provides instructional guides with written text, video tutorials, and visual diagrams, ensuring users understand the drilling process thoroughly. Real-time feedback, including warning and error states, help users correct mistakes and improve their technique. Additionally, the schematic diagram dynamically updates to reflect the progress of the drilling process, facilitating a clear understanding of task completion. The open-ended practice module allows users to apply their acquired knowledge and skills in a flexible and exploratory manner. Users have the freedom to experiment with different techniques and approaches, fostering creativity and problem-solving abilities. This hands-on experience encourages users to develop a deeper understanding of the machining process and enhances their confidence in executing tasks independently. One of the key features of our VR system is its open-ended approach, allowing users to explore diverse methods for task execution. Whether setting up the milling machine or drilling into a workpiece, users have the freedom to choose their approach while adhering to necessary protocol. In our VR simulation, we prioritize open-endedness to mimic real-world scenarios where there are multiple pathways to achieve a goal. For instance, users can freely interact with objects and perform tasks in any order, such as setting up the quill with the chuck and any desired tool, operating and adjusting the speed of the machine, or moving the machine table and setting coordinates. However, when tasks must follow a specific sequence, like drilling a hole after installing the drill bit, users are guided accordingly. We ensure that tasks are not unnecessarily gated, allowing users to simultaneously switch between tasks if practical. This flexibility enhances the realism and effectiveness of our training environment. We see our system as a prototype with significant potential to inspire the design of similar open-ended VR systems for training in manufacturing and other industries. And we would like to express our sincere appreciation to our funding supporters and dedicated team members for their invaluable contributions to this project.